Visit systemsarchitect.io. Subscribe and like this video. In this video, we'll be discussing Zero Trust Agents AI Cloud Architecture. Zero Trust Agents refer to cloud security inside the identity and access management domain. They sit within the Zero Trust model, which grants no standing trust to any actor. A Zero Trust Agent is an AI agent treated as a non-human identity, or NHI. Vendors such as HashiCorp now frame agent security as NHI governance at scale. That means dynamic secrets, short-lived access, and audit, not long-lived shared service accounts. Every action it takes gets authenticated, authorized, and verified on its own merits. An NHI is any identity that isn't a person, a service account, a workload, a bot, and now an agent. Agent identity is the specific flavor of that. It's adorable, a name your systems can bind permissions and logs to. Zero Trust architecture for agents applies the never trust, always verify rule to software that acts on its own. Why does this matter? Agents don't behave like the service accounts you already manage. Hand one a human session token, and you've given it far more reach than the task needs. Agent authentication starts by giving each agent its own cryptographic identity, never a shared one. Workload identity systems already do this. SPIFFE with SPIRE issues signed identity documents that rotate automatically. Identity federation for agents extends that across boundaries. An agent exchanges one proof for provider credentials. AWS does it with OIDC role assumption and IAM Roles Anywhere. Azure and Google Cloud both call theirs Workload Identity Federation. Amazon Bedrock AgentCore Identity adds managed OAuth and JWT flows, inbound and outbound, so agents reach protected MCP servers without baking secrets into code. If you can't name the agent behind a call, that isn't authentication. It's a shared password. Short-lived credentials are the highest value control you can put on an agent. AWS STS, Azure Managed Identities, and Google Cloud Service Account Impersonation all mint-scoped credentials. Their lifetimes are measured in minutes to an hour. Secrets management for agents covers what can't be short-lived, like third-party API keys. Keep those in HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, or Google Secret Manager. Inject them at call time. An agent that never sees a raw secret can't leak one into a log or a model response. Least privilege for agents means scoping permission to the task, not to the agent's job description. A support agent that reads order records has no business holding write access to billing. Capability-based access control goes further. It hands out unforgeable tokens for specific actions on specific resources. The capability carries the permission itself, so there's no ambient authority sitting on the identity between tasks. You'll see the pattern in scoped OAuth tokens and in AWS session policies. The MCP authorization spec, including its 2026 revision, requires audience-bound tokens, so a stolen access token cannot be replayed against a different MCP server. Scope by resource, action, and time, and most prompt injection attacks stop being interesting. Policy as code for agents puts your access rules in version control instead of a console. Open Policy Agent with Rego, AWS Cedar, and Azure Policy all express what an agent may do. They make it testable, reviewable code. Runtime policy enforcement is where those rules actually bite, at the moment the agent calls a tool. A decision point in the tool gateway returns allow or deny before anything executes. Bedrock AgentCore Gateway is one managed form of that control plane. OAuth protected MCP targets, token lifecycle in AgentCore Identity, and tool calls gated at the edge. Reviewing an agent's prompt proves nothing, because the decision that matters happens at the call. Action attribution answers the question every incident review starts with: which agent did this, and on whose behalf? That means the agent identity, the initiating human, and the tool call chain on every request. Audit trails and prove anuns record it durably. Use AWS CloudTrail Azure Monitor, or Google Cloud Audit logs. Write those logs somewhere the agent can't modify, ideally an append-only store with retention locks. Without that chain, you can prove something happened, but not who caused it. Sandboxed privileges assume the agent will eventually do something wrong and contain it in advance. Run tool execution in a disposable environment. That could be a Firecracker micro VM, a gvisor container, or a per-task Kubernetes namespace. Blast radius control limits damage when the sandbox isn't enough. Per-agent rate limits, spend caps, and separate accounts per environment. Kill switches and revocation are the stop button. It has to work in seconds. Test that kill switch on a schedule, because an untested one is a comfort rather than a control. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. Agent-to-agent trust turns into the hard problem the moment one agent starts calling another. Use mutual TLS with workload certificates. Both sides prove identity instead of trusting a shared network. Delegation and impersonation controls decide what an agent may pass on. The safe rule is that delegated scope only ever narrows. Token exchange under RFC 8693 handles this properly. It carries an actor claim that keeps the original caller visible. So what happens mid-session? Continuous verification rechecks that trust during the session, instead of only at the start. The security payoff is direct, since an agent holding minutes-long credentials and a narrow capability makes a poor target. Operations improves too. Attribution turns a vague incident into a specific revocation you can execute. Compliance mapping gets easier when your agent controls lineup with named requirements. Think SOC 2, ISO 27001, or NIST 80053. Security teams also map agent and MCP failures to the OWASP MCP Top 10 and the OWASP Agentic Applications Top 10 for 2026. Those call out token misuse, tool abuse, and privilege creep. Extensibility is the quiet benefit. A clean identity model lets you add the 10th agent without redesigning access for the other 9. There are places where this machinery is the wrong first move. A single internal agent doing read-only reporting doesn't need capability tokens and a policy engine. A scoped role and audit logging cover it. What's the catch with short-lived credentials? A token will eventually expire in the middle of a long-running task. Build retry and re-authentication into your tool layer, or use a durable workflow engine like temporal or step functions that can resume cleanly. Treating agents as non-human identities with their own credentials, scope, and audit trail is what makes autonomous action safe to allow. The core controls are per-agent authentication, short-lived credentials, and capability-scoped least privilege. Add policy enforced at runtime and attribution you can trace end-to-end. Recent practice is blunt. MCP alone is a connection pattern. Zero Trust still needs short-lived, resource-bound login. It needs tool group scopes so read cannot become write. It also needs human approval on risky actions and an immutable audit record. Start with identity and expiry. Add policy as code and sandboxing as agents gain reach, and keep a kill switch you've actually tested. Thanks for watching and listening to this, and subscribe to the channel. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.